it was super.
Is that okay if I record some of the problems that we work on
Absolutely, yeah,
for
absolutely.
other students?
Yeah. So the first question that I actually had was when I was doing number 5 in the assessment, this assessment 11 1A,
Okay.
where there's this like the whole chart, right?
Yes.
Okay. And my brain knows that the answers are back there and I can flip back, but I've been really trying to figure it out on my own. So the one that I came across that and I know that you'll have a very easy reason why this is not right. So I'm hoping you can tell me. Oh gosh, can you see this here? Can you see that? So I
Yeah.
thought, well, 4 and 2, where it's not possible is what the answer is. But I was like, well, can you do the like 1, 2, 3, 4 lines and then have 2 intersecting points? Or
Okay, let me read the directions here.
okay, sure.
So refer to the following table. Sketch the possible intersections of the number of lines. 3 of the sketches are given. So we would need intersections of 4 lines. So this
Okay,
is 4 lines and 2 intersection points. Okay, now I need to look at, now that I've processed it, I need to look at what you gave me again.
it's this one here. Yeah.
Okay, if you extended those diagonal lines, they would hit your perpendicular line.
So if I extended this line,
Yep, and the other 2, they would intersect. The diagonal ones. Here, let me do it for you on the whiteboard. Can you see my whiteboard?
yes, I can.
Okay, now we have a perpendicular line as well that's perpendicular to this one here.
Mm-hmm.
See how if you extended your diagonal lines, they would hit your perpendicular line. And now you would have 3 intersecting points.
Oh, see, and okay, that
Does
makes
that make sense?
no, that, and I, like I said, I mean, I was scratching my head about that one for a while today, and I thought, you know what, you'll be able to just, okay, so, and then that'll make it, so then instead of having 2 intersecting points, it actually would have 2, 3, 4. Is that, would that be right? If you left,
It's not 3.
so you wouldn't count the part where, the point where it crosses perpendicularly?
Oh yeah, there's that one too. 4. You're right.
1, 2, 3. Oh, okay. So that, okay, that cleared that one up.
Figured out how to draw actual lines on here. So
Oh,
that would have to just be sketched. Yes, I'm seeing 1, 2, 3, 4. You're right.
okay. That may, see, I knew that you would clear that up right off the bat. Okay, so and then so finding the 4, like this would be number Oh, so that was 5A. For 5B, it says given n lines, find a formula for determining the greatest possible number of intersection points. And I know that it's n parenthesis n minus 1 parenthesis over 2.
Mhm.
And I went back to the book where it first starts talking about that, and I still can't. I've got a block there as to because I remembered that we had gone over that in class on Tuesday, but I remembered that we did the formula, but I was trying to create it on my own,
Uh-huh.
and I couldn't come up with that formula at all. So what is the rhyme and reason for doing that? I know it works because I can plug numbers in and I can figure that out, but
Mhm.
how do we derive that, you originally? Just
Yeah.
to
So sometimes deriving it, you can figure it out from the geometry, and sometimes playing with the numbers can help you figure it out. So let's just look at some of the numbers that we have here. So the n is supposed to be the number of lines. And formula is for determining the greatest possible number of points. So I'm just going to say this equals our greatest possible number of points. So if I look at that chart, and I'm looking at the answer key now just so I can get some examples. I'm looking at 3 lines could get me 3 points. Are you in agreement with that one? You look at the chart in the back of the book, because we're just trying to find the pattern right now.
yeah, 3. Yeah. So, yeah. So 3 and 3.
What
Yeah.
about 2? 2 lines with how many points?
2. Well, 2 lines, there was one intersecting point and then everything else was not possible.
Okay. 2 lines is one intersecting point. 3 lines had at most 3 intersecting points. Line.
I've got a bunch of dogs, so I apologize in advance.
Oh, no problem. Okay, let's see if we can figure out the greatest number of points if we have 4 lines. So I can see here in the answer key that there's 4 given. The question is, can we get more intersecting lines than 4? No, it was 5. They're showing 5. So the question is, can we get more than 5 intersections if we have 4 lines?
Okay, so with 4 number of lines, which is the n,
So I'm going to draw here 4 lines. I'm going to do, I'm working off of theirs where they have 5 intersection points, and I'm going to see if we can get more than 5.
1, 2, 3.
Okay, what if I draw it like this? How many intersection points are there?
6.
Well, where did that go? Where did my whiteboard go?
I see it.
Yeah, I got 6 as well. You can still see it?
Mhm.
Okay. And on their 3, I don't see any more than 3. You say 6 on 4 lines, any more than 6?
Well, so on 4, we only went up to 5 lines. I mean, no, wait, I'm sorry. Wait, number of lines. Wait, what are you asking?
On, no, I made a mistake there. So we're trying to figure out what's the greatest number of intersection points with 4 lines. So I shouldn't have drawn that one. Okay, that gives me 3 intersection points. We have to play with it now and see if we can get more than what they're showing us. They're showing us 5. Can we get more than that? That's the question.
Yeah, you could take the, one of the lines and then take it from east and west to northeast and southwest. More of a diagonal, right? Two diagonals.
So that gives me 5 intersections.
5.
Okay, is there anything I could do to get more than that?
I don't think so.
So drag this one somehow.
Wait, what if you brought? Could you take that? Well, yeah, could you bring it and cross that line and that? There you go. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6.
Yes, 6.
More than 5. Okay. And that's it, right?
Mm-hmm. Okay, so now in trying to find the formula, you can play with these numbers. So two lines gave me 1 intersection, 3 lines gave me 3, 4 lines gave me 6. I notice that this one is adding. So what you want to look for is patterns. I notice this one is going up by 2, from 1 to 3. And from 3 to 6 went up by 3. So it's making me wonder if the next one would go up by 4. Like, would you have 5, comma, 10 is what I'm wondering and what I'm thinking about.
See, that's okay.
Okay, now one clue is if your change every time is constant, like if it had been +2 and then +2 and +2 with 1, 3, 5, 7, you know that's a straight line. It's linear. Which would only be to the first power. You might remember hearing y equals mx plus b. Does that ring a bell?
No. So if these are,
Like if you had an equation of the number of points equals 2 times the number of intersections. It's n to the first power. If you have it in this format where it's just some number times the n, that's going to be a straight line. And that happens when it's adding the same number each time in the y values as the x values increases in a constant fashion. But that's not the case here. In this one, I see it's going up 2, going up 3, then maybe it's going to go up 4. So this is telling me that it needs to be a higher power than just n to the first. So when I'm playing with my numbers here, I want to be thinking about an n squared or an n cubed or something. So if I multiply this out, n times n is n squared. N times 1 is n. So n times -1 would be -n over 2. So that's explaining to me why we have a squared here, is that it's not just going up by the same amount every time. Now, if we take our number 1 and square it, so 1, no, take our number 2 and square it, we get 4. 4 minus 2 is 2. 2 divided by 2 is 1. So it's just a matter of looking at how can we get from 2 to 1 using a formula. So if I'm just looking at 2 to 1, I might think, well, what's 2 minus 1?
1.
1. Well, let's check. Does that work in this pattern? 3 minus 2. Or no, 3 minus 1
2.
is 2. That doesn't fit here because we need a 3. 4 minus 1 would be 3. It doesn't fit. So my n minus 1 pattern doesn't work, but that's something I'm going to check because I notice, well, from 2 to 1, it might just be -1. But that theory is shot from the 3, 3 and the 4, 6. So then we try something else, okay? What about if you took the 2 and squared it? So 2 squared is 4, right?
Mm-hmm.
If you're thinking, oh, maybe I need something squared. So that's too high. Squaring that would be too high. But you might want to think, well, what's 4 minus, what about n squared minus n? So 4 minus 2 would be 2, but we don't want it to be 2. We need it to be 1. So then you might think, okay, let's try cutting that in half. You see how I'm just playing with the numbers? What about subtracting something to get to the other number? What about squaring something to get into the other number? What about cutting in half? And that's how you play with your numbers to try to figure it out. So in this case, the n squared minus n minus 2 divided by 2 works. So 2 squared is 4, minus 2 is 2, cut in half is 1. Now we'll check it with the 3. 3 squared is 9. 9 minus 3
6.
is 6. 6 divided by 2 is 3. That one works. Okay, let's try it on the next one. 4 squared is 16. Minus 4 is 12. Cut in half is 6. So that works. Let's try 5 and 10. That was my conjecture. 5 squared is 25. Minus 5 is 20. Cut in half. Boom. There it is.
Okay.
So that was my idea, my thought worked. It looks like it's going up by, like the amount that it's increasing is going up by 1 each time. So my guess is that the next one is going to be up 6 and 16.
Wait, wouldn't it be +5? Wait, hold on.
No, the x's are going up by 1, or I should say
Wait,
the number of lines is going up by 1 every time. the number of intersections is increasing. The change is increasing by 1 every time. So first it went +2, 1 + 2 is 3. Next time it went +3, 3 + 3 was 6. Next time it was +4, 6 + 4 was 10. So I'm predicting, yeah, I don't know what I'm thinking, sorry. I'm predicting the next one is gonna be +5. In other
Okay.
words, 15.
Okay,
So
I was
let's
like, wait,
check.
okay,
Yeah,
so
you were right. My head wasn't in the game.
it should be
So check 6 and 15. So 6 squared is 36, minus 6 is 30, divided by 2 is 15.
okay, so okay, that makes more sense because I was trying to do it on the X and Y axis and put it in like that, but then it just I got thrown off by the dividing by 2. But now I see how you just kind of you made it work and then you tried it out and that makes more sense. Now, is that we're going to be given formulas or can we memorize these formulas and that'll always work? Or are we going to have situations where,
Where you have to come up with the formula. Well, anything on the homework is fair game.
okay,
The numbers might be slightly different. So you might have to figure out a formula where the numbers are slightly different than this one.
okay. Oh, yeah. I
You
mean, if the numbers are different, that's fine. But if the formula is different, I didn't know.
Yep, it might be slightly. And you just get better at it by doing more, by doing more of them. Did you get the formula on 4C, problem 4C that we went over in class?
Oh, let's see. I've written on so many different 4C. Yeah, 2. Yeah, so I've got 2 times n minus 1.
Mhm. Now that one, you can play with the numbers, but to me, that one made sense just by looking at the geometry of it. We had, okay, let's say we have 2 points, A and B. So if we have 2 points, how many different rays can I name with just 2 points?
A, B, and BA.
A, B, and BA. So with 2 points, you can name 2 rays. With 3 points, how many rays were we able to name?
So AC or AB, that's the same, right? So that's 1.
Yep, AC is 1.
And then CA is another.
BA is another.
And then to start at B, you could do BA and BC. No, because B, wait,
Yes, you could do B. We can do BA.
BA.
Let's see. Now AB is the same as AC.
But it could,
But
the,
BC,
okay, so we can go back to BA. BC is the same as AC. CA, because that's a new starting point. So CB has already been done. So what is that? Is that 3 or 4? A, C, or AB. CA.
there is AB, AC is the same as AB.
Okay, so BC is different than AC because the starting point is
Different, yeah.
different. Okay,
And then we had CA. We haven't given yet, right?
and then
BA,
BA,
we haven't given yet. What else could we do?
well, I'm pretty sure that's it, right? I feel like that's all we can do.
Which is 4. Okay, now in class, we did 4 and it came out to 6. And we also did 5, which came out to 8.
Okay,
So in figuring out this pattern, you can just look at the geometry of it and see, well, you have to go right and you have to go left. So it seems like it's double something. So 2 times, does it work to go 2 times the number of points? So 2 times 2 would be what?
4.
4, that's too high. What about taking the number before that? Instead of n, let's just try the number below it. What if we did 2 times 1?
2.
There it is. Let's check the 3 and the 4. 2, taking 2 times 3 is 6, that's too high. How about 2 times 2? Times 3 minus 1.
2 times 3, wait,
So if our n is 3, we could do 2 times 3 minus 1.
oh, okay. Sorry,
2 times 2, which is 4.
got it. Okay, right, okay.
Okay, so the fact that it's going right and it's going left is giving us the sense that we ought to be doubling something. It didn't quite work to double n, but it did work to double n minus 1. So this is another strategy when you're figuring it out, is if n doesn't work, maybe n minus 1 or n minus 2 might work.
Okay, and then, so when you had said earlier about if it's consonant, it's a straight line. So that's what you're, because it's going up 2, 4, 6, 8, right?
So we have a constant change. And so that's telling me that the n is going to be to the first power. And not only that, it's going up 2 every time. So that gives me a sense that we're going to have a coefficient of 2 on the end.
Okay, wait, can you repeat that one more time?
Yeah. If I multiply this out, I have 2n minus 2. I can see that my slope here is going to be 2 because it's going up by 2 every time.
Okay,
If it was going up by 3 every time, then you would put 3 in front of the n. If it's going up by 4 every time, you put 4 in front of the n.
oh my God.
So that's another way you can figure it out. Now, another geometric thing that I pointed out Tuesday was, you notice here that I have 3 points, but how many sections does that give me when there's 3 points?
2.
2 sections. So that's another clue on maybe I should be working with n minus 1 instead of just n.
Oh my God, it just started pouring rain here. Okay, so. Okay, so that makes
So you can get hints from the geometry and you can get hints from the pattern.
okay. two segments.
3 points is just 2 segments.
Okay,
So the number of segments is the number of points minus 1 and minus 1.
okay. Okay, so that's a good place for, okay, that definitely clears things up a little bit. As far, because I didn't know, I'm like, well, if that was just a, um, you know, if we just had a formula chart that we needed to memorize, or if you were giving us the formulas, or if we had to figure them out on our own.
Yeah, you have to figure some of them out on your own.
Okay, so, of course, I'm not as excited about that answer as I was you giving them to us, but that's okay. As long as I have the tools to figure it out, then I can get through it. So that's a good jumping off start, at least, because
Okay.
I just, again, it's an old brain, and I got to get back into it. What in third grade, because I stay with the same student,